So here we have h is a differentiable function over all real numbers. That's important. So we can look at the entire real number line. This is the derivative of h. On which intervals is h decreasing? So to do this, all we have to do is figure out the zeros. The zeros, of course, happen at 0, 2, and -1. And because this is x minus 2 squared, we know it's going to be something like this. X equal to 0 at positive 2 here and at -1 here. So we can see that all of these things are really positive. So if you're going to take a positive value above 2, it's going to be like something like 3, for instance. We get positive, this is going to be positive, and this is going to be positive. So we get a positive value. And the way x minus 2 squared works, that means it just touches the x-axis. So it's going to look like this in some fashion. And then x minus 1, because this is a polynomial, we know it's going to cross. Oh, it's going to cross at 0 first, and then it's going to cross at -1. So it should look something like this. We can of course, test the values, right? If we test some large negative number, like -10, this is going to be negative. This is going to be negative, but it's going to be squared, so it's going to become positive, and this is going to be negative. So two negatives become positive, and that's what we see here. It's positive. Test the value between -1 and 0. We're going to get like a -0.5, for instance. This is negative. This is going to be negative, but squared makes this positive. And -0.5 plus 1 is positive. So we have negative times positive. It's negative. Test the value in here, like 1. 1 minus 2 is, again, still squared, so it's going to be positive. So we positive times positive. It's positive, and we already know it's positive on this side. So when is it decreasing? That's when the function is, or the derivative is negative. That happens only on this interval here. That's going to be from -1 to 0, a.